So okay. So welcome to our first main session for the Endelevu Design Challenge training. As we shared the syllabus, this is module 1. So module 1 is going to cover circular design. All right. So again, you all know me already. I'm Nixon Otieno. I'm an architect, as I said, and also a sustainability consultant. Well, the CEO of Nico Green as well, and my contact details are there in case you wish to engage me on any matter separately. So I will start just giving the context of the why circular and sustainable design. And I would use here the term architecture and synonymously with design. And when I also refer to the design, I will not be specific. So those who are not really in architecture should not feel excluded. I would be using this term more or less interchangeably to refer to the act of designing our built environment, built spaces that we live in. So don't feel be offended. And within, when we're talking of built environments and the built spaces, we'll be looking at the building itself as a structure which has many components. It has different elements, and different professionals play a part in delivery of that built environment, whether the products or the technologies that are used, the materials that are used, or the services and the processes that are involved in delivering that particular built environment. So what we are saying is that the act of design of our built spaces really requires redesigning to be able to respond to the challenges of our time. That is my hypothesis, that if we look around us, we see an urgent call for us as designers. And here, all of us, we look at ourselves now as designers, because we are here to in the Endelevu Design Challenge because we want to design and co-create better spaces, Nyonyesha hubs for our lactating mothers and young children to be able to get better service as they focus on their studies, and also the children as they grow. So as designers, we want to be prepared through these sessions to look at how we can be able to respond to the challenges of our time. And as we are all aware, and we indicated yesterday, there are many of the challenges that we are currently facing globally, ranging from climate crisis. We have economic challenges. If some of you read yesterday's Daily Nation, you could see on the front page that many of people have slumped into poverty over the past year, 2021. So economic crisis call on us to create spaces that are able to help us also address the challenges of poverty, the challenges of ensuring livelihoods, sustainable livelihoods for those who are involved in the design and the development of the built environment. Because we don't want to have more and more people, designers, that don't have sustainable livelihoods. We don't want to have fundis, constructors that are involved in the process, but then they are not able to make ends meet. We have issues of social segregation, social exclusion, health pandemics, waste proliferation, and resources that really are getting depleted. Now, all those challenges call us on us as designers to really shift our thinking. We need a radical thinking, change in how we think and approach design, how we look at the spaces. We cannot continue, it is Albert Einstein, I think, that said that you cannot be able to solve the problems with the same mindset that you had when those problems were created. So now that we are living with most of these problems, which are largely our creation, because if you're talking about climate change, and we'll talk about this much later in the subsequent sessions of the following day, they are human creation. You're talking about waste problem. It's a human creations, economic and social disparities. Largely, it's because of the failures of our, economic and social systems. So we can't really solve these challenges conclusively, comprehensively, if we keep using the same methods, the same approaches that we have been using before, which ended up creating this problem. So then that challenges us to think of how we can be pretty radical in how we look at design, to develop new methodologies, new technologies, new solutions, new approaches. And that is why we are all here, to together seek these approaches. And we are glad that it's not only us who are talking about these issues. These issues have been in the conversation for so many ages. So what are some of those challenges that we want to solve in more details, okay? We have already summarized them in the previous slide. But if you look at globally, our built environment, for example, has these challenges. We are looking at a sector that contributes to 40% of the raw material use. So 40% of the raw materials that are extracted globally end up being used in our buildings. And as a result, the same sector is contributing almost 40% of the waste that is going to the landfill. So you look at, we take in 40% of all materials flowing in, from being extracted, and the materials outputs that are going back to the dams, that are taken back to the nature, the earth where they were sourced from, but in a form that the earth cannot use them productively, 40%. And fossil energy, again, we are talking about 40%. The figure would vary between 38 to 40%, depending on what particular energy end use points you're looking at. But roughly, let's talk about 40% of fossil energy. And for fossil energy is a very important factor because it is what is associated with the carbon emissions. Eventually, when we use more of this energy, we have the resultant emissions that come out from them. Look at timber, 25%. Fresh water, and we could go on and on, look at other materials and resources, look at how other sectors are performing. You realize that the built environment is contributing significantly. So that tells us that this sector really must be at the center also of providing solutions to those challenges that we have raised before, okay? Now, if you look at in more details, for example, at country level, the figures even vary. In the US, you look at those figures, you would be shocked. 50%, we're not talking only of, at the global level, we were talking about around 19% of all greenhouse gas emissions and 40% of fossil energy. But when you come to other countries, Hadija, can you microphone? Yeah. Hadija, can you mute your microphone? All right, thank you. And I remind each one of us, unless you are speaking, please mute your microphone. So what I was saying before the interruption was that those figures we are talking about at global scale vary significantly at different regional or national levels. So for example, you're looking at US, we are talking more of about 50% rather than 40%. Yeah, is when you talk about energy being used in buildings and the greenhouse gas emissions. And of course, other elements, if you come to our context, for example, you may find that we are generating not necessarily probably more waste compared to our colleagues or using more energy, but then we are dealing with other challenges that are more severe. And I would give you the figures for our national context. Oh, sorry, I lost that slide. There's a slide that I accidentally deleted. But that slide I wanted to give us an indication, for example, of some of the issues we are dealing with in our built environment. Many of us know that when most of us as students, we actually in campuses, which are largely in urban areas, we know of the sanitation challenges, for example, we are facing in our urban areas, that most of homes, the living spaces that people have, the sanitation facilities are direly inadequate, with over 50% of houses not having a regular supply of water, do not have designed and functional sewerage waste treatment systems. We have many homes that still cannot get reliable access to energy, and especially energy. If we are talking about electricity is good, we have had a great access, but if you're looking for energy for cooking, for example, we have about 78 to 80% of households that do not have clean cooking fuel. So they're using firewood and dirty fuels that end up causing pollution. And that means we're having a number that is very high that are facing the negative health impacts of that cooking with such fuel. So in fact, the figures are, according to the World Health Organization, about 21,560 Kenyans dying every year because of cooking with poor and dirty fuel. While we are using those kinds of dirty forms of energy, we also have access to, abundant access to renewable energy that we are not able to tap. And we have that sectors, of course, that as designers, we are not yet providing solutions for. And so they are excluded from enjoying high quality built environment. In Kenya, we know while globally some are having a forest cover of 10%, here in Kenya, we have less than 7% forest cover. And we're continuing to cut more and more trees to be able to deliver our buildings. And we are cutting trees even within our neighborhoods that we are leaving them bare. So this is having a lot of effect, especially within our cities. So how do we really respond to all those challenges? If you talk about social inclusion, and I mentioned this yesterday in just a quick overview, Kenya, we're looking at 38% of our schools don't have toilets and water facilities. About 44% don't have libraries. 41% of public schools are not fenced. 37,000 classrooms needed in the next 2 years to be able to meet the requirements for the CBC. That the government, in its biggest investment that was made recently, they have only committed to be able to build 10,000 through the World Bank funding. So that means we still need another additional 27,000 classrooms. Forget about the old schools that were already facing inadequacies. If you talk about other issues, especially the relevant to the Nyonyesha challenge you're talking about, 1 in every 5 girls have begun childbearing, and 13,000 of them dropping out of school every year. 16%, as I said earlier, of children do not go to school because partly, of course, they don't have the necessary infrastructure that can accommodate them to learn. So these are the contexts we are dealing with locally and globally. So we need to think and design radically, as I say. So what kind of that design is it? Some people have called it sustainable architecture. You could call it sustainable design. And the vision of this kind of design is to create spaces that are sustainable. Those would be spaces that take less from the earth and give more to the people. If I quote Terry, one of the architects who is really specialized in sustainable design. And the elements, we mentioned them yesterday. There are quite a number, and we are going to look at them in more details. But in a nutshell, if I would really challenge us to think philosophically, how could we deliver such a radical design? I think, to me, we could use, from a layman perspective, because some of us are really not technical in this space, but if we to think about it from a very simple layman, an average, professional perspective, what is this vision of sustainable design we are talking about? That would lead me to ask ourselves the 5 WH question. What is the why? What, where, who, when, and how we are designing? So first, we need to think of what is our purpose, what is our intent, and what is the guiding philosophy or thinking that we have when we are conceptualizing and thinking of the spaces that we are going to create, thinking of how they are going to impact on the people that are going to use the spaces and the other interrelated materials and resources that we use to engage them. What is our ultimate objective purpose? I know some of the architects in the house and when you in your groups will be having very nice conceptual frameworks. You are thinking of your design concept and you come with, maybe I'm inspired by this, I'm inspired by this form. But instead of only thinking of that abstract element, maybe some people may even be as outrageous and tell you, I'm inspired by the mother's breast, and that is their concept for the design. But we don't want to just look at those nice, product and dropping in one. We want to ask ourselves very important question. What is really the agenda that we want to fulfill through this design. So that becomes our philosophy. And then what? And here I'm driven to think about issues to deal with parts. You know, the building in itself, eventually the products that we'll create, whether it is the entire building, or it would be the furniture that we are creating, or it might be the equipment, the fittings, you know, the finishes that we have for those buildings. They have elements, they have, you know, different parts. So what are these, what are the constituents of these particular products, particular elements that what are they made of? Yeah, who made them, you know? So we need to dismantle the building, dismantle the space, and look at it as, you know, broken down into smaller elements. And those elements are constituted of different materials that have different characteristics. And we need to understand what are those characteristics. Then also espouse, building on our why, what is our guiding principle in terms of choosing the constituents for those parts of our buildings and products? And it exists in a place, whether physical, cultural, social context. So we must not design just alive. Some of us have chosen a site to be, say, JQuat, others have chosen UON. While these places are more or less in the same context, you know, it's urban, large, you know, maybe UON probably is more urban in the middle of the CBD compared to JQuat. That is already a distinguishing feature. Is there something unique, particular about the CBD? If people were to walk to UON to look at this particular product, the buildings that we will have created, the Nyonyesha Hub built there, is there something pretty unique about its context that it is within the city? What is the philosophy? What is the heritage of the University of Nairobi? Do UON community have something that they identify with that makes them, you know, we are the University of Nairobi, or we are the JQuat, you know, we are the KU, we are the university, we are too, you know. So we want to understand the people. That could be at the institutional level, the place. Then we also have the people who are the users. These could be the users of the facility. These mothers, are they homogeneous? Are we thinking only of homogeneous mothers? Yeah, they have different, you know, they have different attributes. So what are some of the unique attributes that we can identify? Are we going to design for a particular type of users, or also are our facilities accommodating all potential users? Of course, we are talking about inclusion, so we want to be more inclusive, to have more potential users. But how can we achieve that? It means that we need to clearly define who these people are, what distinguishes them, what are their needs, what are their aspirations, what are their fears, yeah? So then that we are able to internalize all this and then create a piece of work, whether as the entire building product or the building space, or certain elements of it. Of course, we are going back to the issue of parts again, that responds to that particular category. And then, of course, beyond the users, we also have the creators of this space. You people are also part of the creators. You're the designers. We will be working with people to build these things. What distinguishes you people? Individually, but also collectively. So for example, is there a unique philosophy, a unique drive that distinguishes Team Mweusi, for example, from Team Hub, yeah? Or are you guys just the same? Is it just a coincidence that you have met together? Well, maybe it was a coincidence, yes, of course. But now that as you are bonding and you are working together, is there something that ties you, that guides you as a philosophy, as a team? Yeah. And when we move to the construction phase, what are the players that we'll be working with? How do we work with them? And during the use of that facility. So we need to think about this building in terms of the people. When here has a many facets of it. While for us, we are engaging only in the next 2 months at the design phase. The products we are going to create are going to last over 50 years, 500 years, you know. Some of you already know that we have some pieces of architectural heritage that have lasted almost a century. So how would you are building the product you are creating be relevant in a current .com age, in 10 years down the line, 20 years down the line? How are we going to handle also the factors, the pressures of time that you also still have to design and deliver the product within a constrained period of time, 3 weeks. We have to construct it within a very short time or period, but then it has to last and live and be relevant almost in perpetuity. And then how? So this, of course, deals to the issues of process, how, the methods, the plans, the technology, how we are putting the pieces together to be able to respond. So these to me are the 6 P's that are very critical for us. If I was to avoid any other presentation, if we were not to have any other engagement, in terms of delivering this radical thinking, radical design, which we have called sustainable design, with its many facets, let's not forget these 6 P's of sustainable design. Purpose, parts, place, people, period, and process. Or simply just call them the 5W H, which is something we are very familiar with in terms of management. Then in practice, so what does this look like in practice? We have laid the 5W H and all the 6 P's of sustainable design, but then how does this play in practice? Of course, I've already given the overview yesterday. We are looking at bioclimatic design. We have to look at design that is set in its context, different regions, and we'll be looking at the elements more in detail as we go into the particular modules. We have regenerative design, looking at circularity, maintaining the cycle, and we're going to go into this into detail. We want to look at materials. Where are they coming from? What are their, what are they made of? What impacts do the materials have, both into human health, to the local economy, to the people that are using them or extracting them or, repurposing them. Yet these materials, we are thinking they should be renewable, not only, so that we don't really use materials one-off, but then they also need to be durable. We'll be delving in those much later on. So we categorize those principles. For our case, we are looking at them in how many facets? 4 elements of the sustainable design in practice. We are looking at circular design. We are looking at climatic design. We are looking at healthy design, and we are looking at inclusive design. Okay? So that to us is the sustainable design in practice. Now, how do we realize this in practice? As Nico Green, who is convening this challenge and working with us, we see ourselves as what we call the CNS of construction in Africa. That is our vision. I think many of us know CNS as the central nervous system, but we are trying to abstract this word to give it a name, CNS of construction, where for us, CNS is circular, natural, and socially inclusive. So that is our vision, as I shared yesterday. So we want to start with the first element in this session, which is about circular design. And the goal of this is that in that call towards a radical shift in our design, we want to discuss practically, how can we move our built environment? How can we as designers contribute to a just and circular economy? So that is the whole objective of this discussion that we're going to have. Now, this graphic I've given here will summarize all we could say about circular design. The whole objective is that we ought to be mindful of what we are consuming in our design and use, construction and use of the building. So there are those 2 sides that we're looking at, the demand side, and then we'll be looking at the supply side. So first, of course, we want to reduce our desire to extract more. Of course, we are living in, capitalist economy, and we are consumerist society that we want to have more. When we are blessed with our extra resources, we want to enjoy more. Many of us want to live in abundance, but we are being challenged to think of how we can be mindful of the resources we are using. So we want to look at right from resource extraction to the production, manufacturing, packaging, and of course, logistics of moving these products to the sites where they will be used, how they are being distributed, and post their end line. So we'll be looking at elements to deal with taking less, making better, and handling smarter. And I'm going to cover these a little bit more in details. Now, allow me to bring in the issue of circular economy and the Sustainable Development Goals. How many of us have heard about the Sustainable Development Goals? I'm assuming yes, we have some. Maybe if I asked you, probably you may not say exactly how many goals you know, but there are 17 goals. The genesis of these goals were, maybe before I even talk about the genesis, their context. World leaders, of course, led by the heads of our states, all the nations that are members and signatories to the UN Convention. So basically, the 200 plus nationalities that we have, decided that because of those many challenges that we shared at the beginning of our discussion, just at the start of this presentation, there's an urgent need to have a coordinated response to those challenges, that the world needs to move to a future where those issues that we dealt with are no longer a challenge. And then, of course, this was a very long process, that a political process that ended up in coming up with a set of agreements and setting certain goals, which they call, Sustainable Development Goals, that are aimed to lead a vision for the world. Us who are global citizens, whether we are talking as individuals, as corporates, companies, private sector, academia, as governments, to rally ourselves towards a future of sustainability. So the 17 goals were developed, that those are the goals that need to be met. By when? Any of us know the targets, the timelines for meeting those targets for those the goals? Any of us? By 2030. So the world leaders committed themselves to the 17 goals to be achieved by 2030. So there are 17 goals with a number of targets. Now, many of these goals have a direct correlation with the agenda of circular economy. And the principle of circular economy is simple, is to keep materials in perpetual flow. That is to reduce waste and encourage reuse, to encourage reuse of materials so that we don't have what we call waste, that any materials is wasted at the end of its use cycle. So this circular economy aligns with many goals. Of course, I will talk about good health and well-being. We'll talk about clean water. So when you talk about good health, you can see there from the write-up, we are saying that the circular economy helps us remove hazardous substances from, our economies. So if you're looking at our buildings, the circular economy will help us, through recycling, through enhancing continuous flow of the materials. We would want to begin phasing out certain materials. And I'm giving an example here. We're looking at things like asbestos and lead, which I already referred to yesterday. We are talking about, of course, yesterday I also mentioned the health of the people and the planet. We are looking at water. Now, you know that most materials use a lot of water in their both extraction, some of them, but a lot of them in processing. So the moment you take materials and use them and dump them, we are wasting a lot of water. And when we waste a lot of water, in many places of the world are facing water scarcity challenges. So when we embrace circularity, then we encourage the realization of the goal of number 6, that guarantees access to clean water and sanitation for all by the year 2030. Then affordable and clean energy, goal number 7. Again, we know that materials require a lot of energy in the extraction, processing, and actually in use. So the moment we shorten their cycles by using the take, make, waste model, we end up using a lot of energy. So that particular goal number 7 is met by that objective. Of course, decent work, goal number 8. New business models generated by circular economy. You employ more people in the collection, recovery of the materials that are currently being wasted, in the repurposing of these materials, recycling them, recovering them, and creating new products with them. There are those who are involved in the supply chain that would end up, taking these materials to the end users. So those are new job opportunities. And goal number 12 is talking about responsible consumption and production. And this is actually the main goal that the circular economy or circular design principles would be embedded. It would be within the responsible consumption and production. And then sustainable cities and communities, number 11, of course, is focusing on us to create cities. Of course, bearing in mind that we are moving towards a future where most population would be living in urban areas. For the other parts of the world, we already know that many areas of the world, they are already largely urban. But in Africa and Kenya, we know still a huge part of our population is living in the rural area. But this is significantly changing rapidly, with more and more of the nations in Africa and other parts of the developing world becoming urban. And the conditions of living in these urban areas have been challenging. So embracing circular economy guarantees better quality of life, better spaces for the urban dwellers. And lastly, the climate change agenda would be addressed by embracing circular economy. And we will talk a little bit about that when we talk about the circular design. Now, I'm going to go into a little bit of the 3 things I mentioned: the take less, make smarter, handle better, and how that can help us achieve circular design. Then I'm going to come back to the key design principles, if time allow. What time are we? Okay, we still have time. But before I get to that, the theory, let me just pause for a moment and give an example of a very simple thing, a simple material that when we were designing this particular program and Endelevu as a platform and as a program, we thought about. Think about me talking about 41% of our schools, public schools, not being fenced. And that means being exposed to land grabbing issues. In a particular year, we had cases reported of 250 schools being land grabbed. You remember, of course, in the news a while back, there were drama around the schools like Langata Primary School, which other school in Kisumu, a lot. So this is something we live with. But apart from land grabbing, when people just pass through the school every now and here, then the way they look at, the way they prefer, it also means that is a lot of interruptions for the learners. One of the reasons, of course, is because of the infrastructure challenge that the schools are having, that they don't have adequate classrooms, they don't have other facilities, tuition facilities that are critical, and they are limited in budget. They don't prioritize fencing. So think about a material that we are currently using in our construction sector. We use cement. Cement is a major construction material we use, right, in the country. Because of concrete. Concrete is a major building, of course, how do you call it? It is a mix of material. Concrete is a mix of materials. So it is a major material we use. So in Kenya, in the year 2020, we actually 2019, 2020, we used about 6 million tons of cement. Yeah. In the last year, up to the period July, this figure actually rose to 7.2 million tons. So within a year, because of the rapid increase in the infrastructure with the Big Four agenda, we have seen, the constructions that the Jubilee government have been undertaking. There was a significant increase, but just take the 6 million tons. And when we did this, our rapid applied, study, research, if you analyze these bags of cement, the 6 million tons, of course, our cement is consumed largely in bags. There is a bit of bulk cement, which constitutes less than 5%. So if you're looking at that 6 million, almost more than 95% of it is consumed in bags. And these bags, they are 50, of course, 50 kg bags. So that gives you 124 million bags of cements that are used in Kenya every year. Those bags are largely made of plastic, woven propylene plastic, right? Of course, I wouldn't go into the details to give you the statistics, the figures on how much weight of that plastic is, yeah? Now, if you think about those 124 million used plastic bags every year, and currently what happens to them, if you go to the construction site, you'll find they are torn like that, and at the end of the day, they are dumped on the ground, so they end up going into the drainage channel, or you find some people on the sites are burning them. So these are very toxic materials that are emissions that are really going into the air, or they end up into our channels, blocking, and you see every time it rains, most of our urban areas are flooded. If they eventually they get themselves washed, where do they end up? They end up into our rivers, they end up into the ocean. And so that becomes part of marine pollution. So that is a major issue that you're dealing with. And part, of course, these things, they will take a while. Sometimes fish ingest them, they're thinking the material that fish end up back, some of us eating it. So it's a major issue. So we thought, what if we took these materials, and the solutions are already there out there, and we were to reuse the cement bag? Our calculation showed us that we actually could be able to fence over 2,000 schools. And if you're talking of the school, imagine the perimeter, some schools being 4 hectares, in size, you are able to fence about 2,000 schools every year using those materials. And this one will divert 3 million tons of construction debris. Remember, also on construction, we have waste, either you see like plaster, those bulk aggregates, or it could be the soil from the excavation that again gets dumped. So if you were to think of the cement bag, if we were to encourage reuse of these bags, just cutting them in a very nice piece, then refilling them with some of the debris from the construction site and create something like that. These are earth bag walls, for fences that will be over 2,000. Then you'll be talking about your fence, 2,000 schools. And you'll have diverted these 3 million cubic meters of debris from being also landfill. And in the sole process, we'll have 53 million tons of carbon dioxide emissions. These are greenhouse gas emissions, which contribute to climate change. So you can see just by that one simple action, how much we will have contributed to saving, how many children will be having better schools that are protected, well secured, so they will not need to demonstrate because their land was grabbed since it was not marked. Yeah. To give you another example of something that we were considering at the office, this is one of the projects. If you go to Endelevu site, Sigoti Complex Girls Secondary School. This is a girls' school in a part of a rural village in Kenya. The school has grown rapidly because it is purely a girls' school and a boarding school that is addressing the needs of the girl child within that area. So it grew within 5 years from a population of about 400 to 1,200 girls all boarding. And those girls, they don't even have a boarding facility. They don't have a library. The one they have is a bookstore, which is just a classroom that is converted to a bookstore. They don't have a dining hall. They have a lot of infrastructure challenges. And even laboratory, they only have one science laboratory, yet they have to handle all those streams of girls. So whatever money they get anyway, they will not be able to build library, they will not build reading spaces, they will not build dining hall. What they are currently focusing in is to add the additional classrooms, then later on construct some more extra dorms because the spaces they have are limited. So we just engage our mind, for example, thinking, what if we were to think about the waste that come from our sites and we were to divert it to create, for example, for them a small transitionary space, like a reading space. So we conceptualize something we call readine. So readine is a read and dine. So it is a multi-purpose space where you can read and dine at the same time. And we are using the pockets of space because that school, again, it is on 2.5 acres of land within a rural setting. So you can imagine 2.5 acres of land for 1,200 girls boarding. They don't even have a play field. So the spaces, the buildings are really, I think I didn't include the site plan here, but you can imagine the spaces are very squeezed. So they are still looking out for land where they can buy so that they're able to play. So the space is also limited. There is no space even to put a dining hall. Eventually they'll have to do a multi-storied building so that they make good use of spaces. So what we thought, what if the smaller in-between spaces, the spaces between the blocks, the existing single-storied buildings that they have on the compound, we could use them as multi-purpose spaces where these girls, instead of them queuing, picking their food from the kitchen and then carrying the food to their classrooms so that they eat in the classroom to utilize their lockers, and then quickly convert it into a classroom back, wipe their tops ready for classes. That we could convert that transitional spaces to a reading and dining space. Now, if you look at this solution that we were thinking, for example, these are materials that are from waste. So you're looking at here, like we have, for example, a bench. This is a reading bench. You are looking at probably these are timber, maybe from the scaffolds that are used in the construction, or they could be, you see, probably broken door, furniture, whatever those, we repurpose them, make them very nice, create very nice rustic feeling. Then these are broken tiles, different assortments of tiles that you create patterns and nice collage with. These are broken, some of the debris that we then complete vizuri. Hapa chini ya kiti, we provide cabinets so that they're able to store their books under there, or and on the walls also we intend to provide cabinets also the walls. So both they could store their books, they are under the logs, or store their utensils. We're thinking of that onto the walls as well, that we could have cabinetry, use some of the off spaces that are empty, make them look very nice. This one you could see the section. So you have the cabinets under, the girls are studying there. And then at one point, it is a study space. After lunch in the evening, they use this as a reading space. This we are using, steel that is discarded from site. We collect water. This was a membrane. At this point, we had an idea of collecting, for example, the membranes. You look at the PVCs that come from events. People having tents, you're having this activity, they gather tent, that material is thrown away. So those canvases that are discarded, we are considering if we have those as the membrane, that we then collecting water, coming through that, and that water goes, we collect it, is recycling it. So we're using it for gardening, and you can see there we have planters that are held within. So you're reading, and of course, what really the importance of plants we'll talk about later. And I know already the architects and some of you colleagues that the environmental scientists that in the room, the nursing colleagues that are there already appreciate the importance of the plants to health, especially where we are studying and working. So if you're looking at that kind of a simple solution, that we are able to repurpose the couple of materials, do nice paints, create a space that is functional, is transitional. This is just to give you wild ideas. I know you guys will be coming up with very creative ideas, but then those ideas also, they have to be practical, and you have to begin thinking, what are the possible materials? Well, even though you have not done waste mapping, and your waste mapping may only give a limited materials in campus, but think around the built environment. What are some of the things we could go get in the city? So for example, here we were talking about this membrane. We know it was not necessarily there in the school, but if you think around, for example, before we had COVID, how many events were happening, like ACC holding these ones, Safari, where they are having so many events, people are going for wedding, and they create these spaces, then these tents, they get thrown away. What if we were to repurpose them? You could begin thinking of more and more things. Like in the campus, you have blankets, that are worn out, thrown away. Of course, they are fiber. What would happen with those? So you think in and also without, and see how this can be recreated. Now, I want to end that at that point first, take reactions, then I'm coming back to the 3 principles of take less, handle better, and smart as the key component of circular design. Then I will come back later with now other further practical strategies dealing with things like design for disassembly, design for more the nitty-gritties of the details of how we are going to be able to make achieve circular design in real practice. So allow me to pause at that point and take comments, questions, feedback before I proceed to the next slide. I open it to you. As I said, this is a conversation. It's not per se one-way lecturing. I'm the expert and you guys just the sponges to soak in everything. I think we are learning together. So any reactions? I open up the floor. Hello, who is speaking? Are you speaking with your colleagues in the background or are you speaking with us? Okay, if there are people who don't talk, I will just ask, then I'll just ask you individually. I'll sample a few people to share their comments. Here with us is Immaculate. Immaculate, we didn't hear your voice before. Immaculate, any comment or question? Immaculate, are you there?
Yes, I'm here.
Could you share what from that conversation, from that presentation, what really intrigued you? What did you get maybe as a key takeaway, or what intrigued your thinking? What really was going through your mind as you were following the presentation?
I was intrigued by the ability to reuse the materials that have been discarded maybe from one site to be able to create, to be able to use them into other projects and control the waste that goes into the environment. That is the part that really intrigued me the most.
Okay, interesting, good. Thanks for sharing. And someone else? Brian,
yes. Yes.
We would love to hear your reactions. Welcome.
Thank you so much, Mr. Nixon. You've talked about waste assessment or something like that. Will we be limited to whatever materials we'll identify from the waste assessment in the design? Thanks.
Good question. Yeah. A good question. No, we wouldn't. As I said, when I was giving the example of what we were conceptualizing for Sigoti School, you will not. I said, of course, we will do waste mapping for the campus, what is available within, but also think of what could be sourced from outside. And you need not just to think about it theoretically only, but also as you're thinking what could be potentially gotten from outside. It should also be feasible that if we set out to go look for it, we would be able to find people with it that can actually give us that material to use. Let me give you, for example, a quick example. Like if I talk about timber, maybe you may not have enough timber in campus, but we could, for example, theoretically approach those who are in the shipping industry to give us timber. Or if I talk about tiles, yeah, we know tiles, there may be no tiles as much in campus because there are no active constructions that are ongoing or demolitions that are ongoing. But we know outside, most sites are active where people are building and they are flooring, you know, they're doing tiling for their floors, and we know there are many broken pieces of tiles that are there. Or there are many broken tiles in transport or at the factories that are being handled. So you could very boldly be able to say, look, we could go and approach tile and carpet and tell them, oh, give us all the tiles. that are broken in your processing, we want to work with, or we would go to the hardware and ask them, what are these pieces that are broken off, and give us as an example. So we are not limited to what we will find from the mapping exercise in campus. In fact, of course, the next session before we conclude this circular design, we are going to look at mapping and what are some of the materials that are potentially will be salvaged. If you already read some of the references I gave, you realize that there is already a list of most popular salvageable, recoverable materials that we can find that can be part of your design palette as you're looking, beginning to think about your design. But think beyond. For example, excavation. If you decided later on, even after our session on the natural materials, like the way I was giving the earth bags, I'm talking there about cement bags. You may not have cement bags, used cement bags in the campus, but you know, just nearby the campus, there are many people who are building. So we could approach those contractors and tell them, oh, guys, please cut these cement bags in this good way so that we will come to pick them or keep them for us because we want to use them, because you know you are going to use them for a certain purpose. I hope I answer your question, Boyd. We are not limited to what could be available on campus, but also we're looking at what is available from outside. But the caveat is that they must be practical. There must be things that if your design won, but even if your design doesn't win, because we'll also be taking some good elements of all the designs that are submitted, that we would be able to set out, get them, procure them, and build with them. Because here is not, this is not like your school project where you are amazing your lecturers with your proposals and it looks very nice or theoretically. But here we are thinking of, yes, it is theoretically achievable, but can we practically go test it ourselves, working with other collaborators and partners to make it happen? Thank you. Okay, any other feedback? Joshua?
Okay, mine is a concern. When it comes to waste salvaging, right? Let's say we've gotten maybe blankets and so on and so forth. Won't it take the overhead charges higher because now you need to find a way to fabricate them into the elements that you want? Maybe it's the cement bags. You need to have some skill sets so that you can actually get them to usable parts for the design. Won't that in turn bring up the charges that we're going to incur?
That's a very good question, Joachim. Can someone respond to Joachim's question? I know we have some few people from construction management, quantity surveying here, or just other people. What do you think? What do you think about Joachim's concern?
Hello, I would like to contribute about Joachim's comment. So in the process of construction, or let me say waste management, there are 3 stages. There is the reduce, reuse, and recycle. So the option on recycle usually costs less as opposed to recycle. I mean, the reusing usually costs less to recycle. So even the process of making the material to be reusable, it costs less in terms of energy and in terms of the financial part. And again, most of this waste goes unused. So you have the advantage that you won't be purchasing the material. So that's my take on that.
I'm still not content with that, because now consider this. If I have, say, aluminum that I want to fabricate and use as a structural element, right? And I have the option of using steel, which we already have available skill. Won't me buying steel and using the already available workforce be easier than me recycling the aluminum, and I have now to train people so that they can be able to recycle the aluminum properly?
A very interesting conversation. Maybe another opinion in between. What do you think? Maybe one of our sisters can help us. Prudence, what do you think? Okay.
Okay.
Yeah, go ahead.
Kindly, Joachim, please. I didn't get it quite well. I'm trying to decipher the question quite well. Would you please just clarify yet again, please?
Okay, so previously we had another undertaking. Also, it was a competition. It was at KQ, it's called the Fahari Innovation Hub, and we used a lot of recycled materials. But what I noted from that was that we didn't have the necessary labor force or the necessary skilled labor to actually fabricate the materials. And this staggered the time, and also it staggered the financial aspect of it, because now we had to find people who can actually actualize what we wanted. And this brought about extra cost in terms of paying the labor and all that. Though we were saving on buying the materials, but now the labor costs went higher. So that's what I mean.
I think Joachim has a legitimate concern, which I'm not be able to comprehensively address, but I think there are some cases where already recycled things are in the market. For instance, recycled steel for enforcement, things such as recycled timber from construction sites. So I think for cases where the waste is already available in ways that can be used, it might be cost saving. But I think for the case where you might need to refabricate the waste that you're collecting, I think Joachim is raising a very legitimate concern in matters of time and cost.
Good. If I may interject, yes, on that, absolutely, a very valid point. Oh, sorry, before I go, Immaculate has a comment. Immaculate, go ahead.
I think that when you're using recycled material, when you're using the material, it is going to be considerably lower, because when you are building up rates, for a new material, you're going to consider the material and the labor rates. But when you're looking at the recycled material, you're only considering the labor for restoring and working on the available material for it to go back to the usable standard. And though we are having the concerns for the rate for the labor may be considerably high, but ultimately we can look at the total cost, the overall cost, so that when we have included both the material and the labor, which option is going to be cheaper. And for me, I think it's still it is going to be cheaper than using new materials.
Great.
Thank you.
Thank you. Someone else is commenting?
Yes, Nixon.
Yes, go ahead.
Yeah, in relation to that, I'd just like to support Immaculate and the person who has just spoken right before. I think that we are just trying to achieve a harmony between cost and cost and labor and construction generally. So you will outsource already recycled materials rather than having to get people to train and actually prefabricate the whole thing once again. So that's just what I think, that we are just trying to find a place where we are saving on cost and still working on the project.
Great. Very interesting conversation. I hope I'm not locking out anyone who wanted to contribute to that presentation, that discussion.
Just a parting shot. What I'm saying is recycling is important. And at the end of the day, we have to find means in which we'll have enough labor, enough skilled labor to be able to achieve what we want to achieve. But in regards to that, it might not be an instant thing. It might take a while, yes, but it's doable and it's possible. But before we synchronize between the cost of the labor and the cost of actually doing it with new materials, we'll have to actually take some time and actually be able to incorporate it into design.
So good. Sorry, I was having an issue accessing my screen. Yeah, very good point. I would agree with all of you, and I would just make a comment on a concluding comment on that. Of course, I will begin by saying that these are the concerns that informed partly also why we developed the Endelevu program itself. And number two, specifically the design challenge. Are you seeing my screen? I'm sharing a screen briefly. Are you able to see my screen?
Yes, we can.
So just when we're in that context of conversation, I wanted just to expand the conversation, and then I would respond conclusively. Of course, building on what we have already discussed. These are the barriers to reuse in the construction sector. And this is based on a study. One of some of the references that I will share with you there, you will find this. This was a very rigorous empirical research done on the challenges of reuse. So if you look at here, the barriers, there are two sides. On those who are contributing the materials, but there are also the barriers on the sides of those who would receive those materials in their projects, okay? So if we look, for example, here, while building on the concern that Joachim has raised, there are limited demonstration options. So as we already said, some of you sharing your motivations in the morning, the marketplace, this is not the common practice in the marketplace. So there are not a number of projects that are live. You can go to look for case study. You can see they have tested, done this and it works. This is not what it works. So there is limited such projects. Quantities of materials is also a challenge that sometimes you may want, if you are to look at your real project that you are involved in, like say Nyonyesha Hub, if it was in the real traditional marketplace that you are a client, you have a client, you're building quickly, you are time bound and you want to get this guaranteed supply of the materials and finish, you may find that if you opted that you wanted to use a particular material, probably let's say you need 100 pieces of that particular time, but then immediately within the timeline you have, you may find you are only able to access 2 or 5. Yeah? So the quantities, guaranteeing the access to the quantities are sometimes is one of the issues that are also facing the reuse within the construction sectors. Program that has to deal with, the timelines. Projects are normally some of the main, one of the 4 main things to control in the delivery of projects is the issue of time. Projects are time bound. People, of course, consultants are pressed on time. As a design team, you want to design so quickly. Once you have won the project or you have been commissioned by the clients, you are under pressure to maybe within 1 week, you have done preliminary design, you have presentations, tendering need is required. While you're doing that as an office, you're also running the other things. So you're under this much pressure. It's not like the reality in the school where you sometimes have 4 minutes to probably 4 weeks to develop a project. But reuse, as Joachim was saying, sometimes would require, you don't necessarily have the skills that are there. You want to test these materials. You want to go find out, recover, where are they to get. So it's time involving. sometimes. In most cases, those were the finding. Limited knowledge, whether you're looking at competent people who are able to work with certain reused materials to give you the same quality. No passports mainly deals with the fact that, you see, when you are buying a new material, sometimes it's very easy to get the product declarations. You know, who is it from? Sometimes you'll be able to even get tests that have been done. There are quite clear labels on some materials and you be able to follow them through. For some of the reclaimed materials, you may not have that data. And as a consultant or professional, sometimes you will not want to take responsibility, because you know if there is a problem with the material that has the data challenge, if it was not working, the manufacturer already has provided guarantee. And if it fails, you will just go lay a claim based on the warranties and guarantees they provided, or hold them liable, accountable. But in this case where you don't have such guarantees, then that links with the issue of liability. You want to be assured that you will achieve the technical performance required, be it thermal, structural, safety issues and all that. And sometimes that data may not be available for the reclaimed material. They are not standardized, how to deal with. Sometimes we have been used in the design that we focus a lot more on standardizations. We want very precise, standard modules for us to deliver component. But the reuse does not give you standardization. You have to embrace that, diversity. Storage, yeah? Where to put this place in the construction site? Probably you want to use it for. So storage is a limitation. Yeah? Network, that who are the people who are providing these materials? How do they link? Those who are creating, who have the materials, those who need them for the project, and also the fundis, that the suppliers, contractors that need these things. If you're coming to the other end, the same. Some of them are mixed. You will still have issues to deal with quality assurance and all this. So now, when you consider all those factors, there are some of the issues that have been making reuse be a challenge to become mainstream. Now, part of Endelevu is to address these barriers. And one of them, like we have already created the marketplace so that you have visibility and you're able to connect those who need the materials and those who require them. We are dealing with the issues of quality and man workforce, like Joachim was raising. Why we are working with you guys here? We are trying to develop standards, to develop designs. We don't know how much it costs. I agree, hypothetically, I agree with what Joachim raises, that it would cost more to be able to repurpose the materials, to be able to sometimes transport them and get them used in the site, because you don't have established market, logistics works for it. So if you're looking at as an individual project, it may cost more to be able to prepare those materials. But we don't know, agreeing with what Immaculate and Prudence have shared, how does it balance off with the fact that most of those materials, in some cases, you will get them for free of charge, or you will get them at a subsidized cost. But if you were to balance the reduced cost of getting the materials, buying them, with the cost involved in preparing, the labor involved, the resources involved in getting them actually ready to be used in the building project, would you be able to say at the end of the day, it is net cheaper or it is net expensive? We don't know. We don't have tangible facts for different material scales. That would vary for different materials. It would vary for different sites, because, for example, if you are just collecting within the same site, for example, at the university, and reusing it there on site, you have no issues to deal with logistics, right? If that is different from if you are taking tile from industrial area to bring to University of Nairobi, and you are only having 2 boxes of tile, even if you were to hire Uber, you would pay the full transport for Uber to bring you that 1 box piece of tile. That will be, the transport alone would be more expensive than if you were to walk to Kijabe Street just next to the university and buy 1 piece of tile. You see, those dynamics are different. So they have to be analyzed in that particular context. Then, having said that, I also want us to think of the other element that we'll be discussing when we are talking about climate issues and all, that we also need to think about life cycle cost. Here we are only talking about the cost at the design and construction. But then when we think of the buildings and the product, we also want to think about what is the life cycle cost of that product. okay? And if we bring the life cycle costing element, then absolutely reused materials would be cheaper, whichever way you look at it. Because the moment you bring life cycle costing, you want to look at that tile. If we are taking tile, for example, from its grave, from where it was the cradle to grave, from where it was sourced, extraction, processed, up to the point it has been delivered. You'll not only be talking about the cost on the shelf, the value of 800 shillings, but you'll be talking about the lifetime cost from the extraction to the use to the disposal. Sorry, someone has not muted. So why it is important for us to involve in the Endelevu design challenge is you will not only be designing, you will also be critically looking at the cost elements. And that is why we encourage teams to be multidisciplinary. Though we have not had many quantity surveying colleagues registering, we had hoped that at least you would be able to have a multidisciplinary team that you not only are looking at the design aesthetics part of it, performance, but also structural, chemical, mechanical properties of these materials, but you also want to look at the logistics, supplies of these materials, the social aspects of these materials, analyze the cost so that at the end of the day, you begin to appreciate those dynamics. And eventually, for me to conclude my submissions on that particular element, the absolute advantage of Endelevu design challenge is to help us develop a critical workforce of people who understand working with the reused materials, not theoretically, but have also tested them, and we will be generating data. You guys are in the universities. Where do we have places to do research? It is the university. If you go to the engineering labs, they test, you can be able to go there. If you're talking about the structural performance of a certain element, you not only want you to think about it theoretically. In the long term, we look at a scenario where we are able to test some of those materials. If we are talking about the joinery, we want to look at, for example, the circular design principles that we'll talk about later. For example, we don't want to encourage welding because you want to encourage ease of disassembly. We want to do bolting, those joints that are easy. But we may not be sure for certain elements, if we didn't weld, would it be strong enough? The structural engineer may be concerned, would that joint be strong enough to support that load compared to if it was welded? We don't need just to guess. We need to test, do calculations, work together, but also we would be able to test this. And we are partnering with the National Construction Authorities, very interested in what we are working on. We want at the end of this challenge, and once we have done 10, 15, 100 Nyonyesha hubs, we will be having real case examples and seeing where these materials are. We will be able to begin talking when you go to the Endelevu platform, the marketplace, you will be able to tell, yeah, these are the fundis, these are the welders who know how to work with these materials. If you go to Nyeri, you can find fundi so and so in the touch of your button, so that the logistics, the costs that are involved with the labor, the personnel that are working on these people, the ambiguities about the standards and the performance required, we begin to solve them through what we are doing, so that at the end of the day, we inspire a large-scale transformation of the market to embrace circularity, because offices are busy and tight. As a designer, as an architect, as a QS, architects has given you the drawing, they want you to deliver the estimates tomorrow, the clients are waiting, you have a presentation. You don't have time to do those calculations. So through the Endelevu platform, we want to answer those questions, have more tangible evidence and data, and also have the connections, the marketplace, that you know who to go to, where and when, if you need this particular challenge. So that is our aspirations. As at now, we don't have all the answers, but as we are working together going forward, we want to improve the ecosystem. We want to limit these barriers. We want to address these barriers as we are going along. So that is the entire spirit. I agree absolutely with you, but then we don't have all the answers. Let us go work together to find those answers. Let us continue questioning. We must question critically the way Joachim has raised, but let us not be narrow-minded. Let us, as we question, we broaden our thinking to look at all the options that we have, and remember that we are the ones that are providing the solutions for the industry so that the industry can truly move towards a circular economy perspective, a truly sustainable design perspective, because we have unlocked the barriers, we have created enablers for them to be able to actually make it practical in their real day-to-day realities, that they don't have 4 months, they don't have all these people in their offices to go analyze data, they don't have people to go send to pick this material here and come back and forth. I hope that really responds very well to the concern raised by Joachim. Joachim, I saw your hand was still up. Is it still a further question on that, or you forgot down? Is it that you forgot to lower it down?
Yeah, I forgot to lower.
Good. So then we have 6 more minutes. I know we started 10 minutes late. I had promised that we will handle this session for 1.5 hours. So I have, I had a bit of a slide to show on the 3 elements: take less, make, to address the take, make, waste. So if I may seek your indulgence, can we take a few more minutes, even if we slip beyond 1 slightly, that I can cover that, so that tomorrow we go into the nitty-gritties of the design for other elements like climate and health. Would you allow me to take probably another 10 minutes extra beyond? We can finish, say, latest 1:10 or 1:15.
It's okay.
Is that okay?
Yes.
It's
All right.
okay.
Yes, yes.
All right. So then allow me to project another presentation here. Okay, I'm sharing my screen. Okay, are you seeing my screen?
Yes.
All right, thanks. So just building on the conversation we were having, just a bit of data, and of course, why it is important. You'd see there 80% of biodiversity is lost. We have plastics, 91% of plastics not recycled. And this is a major issue. And interesting, Joachim was talking about them thinking about plastics. And in the construction sector, you know, plastics are all over. We have them. We have them in many products. And one of the resources I'm going to give us when we'll be talking about the healthy design, healthy materials particularly, you would be shocked to discover how much plastics we have in our buildings. But this is the data, some of the research that has been done showing that every year we dump about 2.1 billion tons of waste on the planet. Yeah. And remember that 99% of the things that we buy every month, we throw them within 6 months. So of course, if you could think about that as a building, of course, we don't throw away our building within 6 months. But there are certain elements in our buildings that we throw away so quickly. So think about it this way. We need to think then, how can we encourage, as we are designing the building, to reduce, of course, the waste? So we talked about reuse and all those elements, but we also need to think about, if people, why are people throwing away? How could we incentivize people not to throw away quickly? So if we were to continue at that rate, of course, we already know that we would need 75%. We will be, by 2050, the amount of resources will have been consumed will have increased by 70%. So that means we need to change. And we are also saying that this is a systemic issue. Just like the way Joachim had shared, and he had just shared one of the issues, and I shared that the challenge we have about the barriers. It is a systemic issue. So what it tells us, if it is a systemic issue, is that also we need systemic solutions. So we need system thinking. It needs a whole system thinking. We did not need to compartmentalize our thinking, be very specialized, narrow focus. I'm just an architect or I'm an interior designer. I'm only looking at furniture, so I don't really care about what, or, you know, as our role is to design and build, I don't bother about how the thing is being made or what happens to the end result, the end cycle. That is the responsibility of the environment department of the city to deal with what that waste. We need to think about it in the entire, as an ecosystem issue. So the real elephant in the room is that this is how currently we build. How we deal with our product. We take, make them, and then waste them or dump them away. But for us to be able to move towards that a circular economy, we have to embrace that. And remember, I said we discussed this in more detail. We need to take less, we need to handle smarter, and we need to make better. So how do we do that? So for example, taking less. How can we inspire the use of fewer natural resources and consume more mindfully? How would Nyonyesha Hub and all other designs that we would be dealing with in our entire professional life? How can we encourage more people to use less and less and consume mindfully, right? What are the practical ways, strategies that we can use to achieve that? So what are the design opportunities to encourage people to design less? The questions we are asking ourselves are, how can we inspire new narratives that go beyond endless mass production and consumption? And one of the things, of course, as Joachim was raising the concern, is because we are in an industry sector that's, and this has been, of course, the result of globalization and industrialization. We have moved to mass production of products and buildings that when we were building Kitambo, we were building at a local level. We were not so much bothered of how effective and how efficient. You see, we have standard processes, we have mass produced processes that now, because of the economies of scale, have become cheaper because the logistics are well established. The personnel around them have been so specialized. We don't necessarily have to be depending on mass production as the only way to reduce cost. How come you can be trained in the school for 6 years, trained in architecture, trained in quantity surveying, and when you are studying the materials, we are only looking at tiles. We are only looking at all those mass-produced, industrially processed materials, so that we don't have the workforce who know about other alternatives. Yet, in our villages before, we were able to create materials at the local level. We were looking at how to harness sand, how to harness those other materials and produce materials. So how can we, in the modern area, with industrialization with us, these technologies, high-tech system, still be able to produce materials that not necessarily exclude the need for localized production, materials and technologies that within the context? How can we help people imagine possible zero waste futures? Zero waste is where there is no waste, yeah, at all. How can we revive repairing, restoring and sharing practices? We're saying revive because in Africa, in many poor societies, if you look at ushago hata tukienda saizi, people reshare. People don't throw things anyhow. Yeah, before something is thrown away, it has been reused and reused severally. How can we embrace this in our thinking? Even as an office, as an architect, you're designing, you know, as an environmental scientist, you're contributing to that product. How can you think of your building encouraging resharing? We are talking about individual products, individual systems within the building, but also we are talking of the building at our outset. How can we simulate, how can design simulate alternatives to buying and owning products? I give you an example, and some people, if you search, for example, TAN2 is TURNTOO, and this was a very creative architect who was exploring something very innovative with the Philips. Those of you may know Philips is a brand name we are familiar with. They have bulbs, lighting system they're using in the house. So for him, he was pioneering a case where we don't need to buy and own everything. Most of us, all we need from a phone, for example, we don't need the gadget. We need communication. or let me bring it to the building and relate with what Tantu was doing. If you look at your lighting as a building, what do we need in the building? Do we need the bulb or do we need the light? We don't need the bulb, right? We need the service, right? So we need to buy the bulb, not to buy. We need to buy the light. So what the architect behind Tantu did is that he negotiated a contract with Philips that we are not going to buy for the lights. You will provide as light hours for this building. So the moment that your bulbs are broken, you will come back, take the bulbs, and still guarantee us that every day we will getting these lumen hours. Of course, lighting is measured in lumen. So we need this quality of lighting and for this period. So tell us how much you will charge us for lighting. The same we'll talk about with electricity. We already knew it is existing. We don't buy a power production station from Kenya Power. We are only paying for the energy they are giving us. So can we scale this as a design? How can we encourage more things like, looking at products as a service rather than just the product, so that we are not buying more and owning. We move from owning economy to more sharing economy, leasing economy, things like that. How much we broaden our understanding and practice of sustainable living by learning from perspective around the world, those best cases that are already there. How can design enable communities to reduce consumption and wasteful practices? So those are some of the things that we want to think about. The second element, making things better. How can we make products and materials that are kept in use and regenerate natural systems? Again, think about this as you are working on your system. Products, services, and systems are designed with little regard for waste and overall environmental impact. Services and systems, we are saying, currently favor profits for people rather than profits for planet. Products are not designed to last, and a single-use design mindset dominates across many industries, including the many industries that are related to our construction industry. Products are not designed using sustainable materials or processes. How then the design opportunities we are looking at for us to make things better here? How can we use biomaterials to replace ancestral materials used for packaging and products? How can we build products designed to last? How can we encourage the awareness and use of more sustainable materials among designers? How can we enable the constant use of materials in continuous closed circles? How can we rethink logistics, distribution and delivery systems? About reviving also traditional and sustainable ways of making things. Remember repairing and things. We have many artisans that are around. It is interesting that Joachim is talking about refurbishing things being expensive. But Joachim, do you know how many fundis, how many welders, how many carpenters don't have jobs, sustainable good jobs to do? And those people are lying idle, they could do that work very cheaply. How many workshops do you know we have in our TVETs that are well equipped but are lying idle in the year? Some of us, even within our university, how often have you gone to your wedding fabrication workshops within the school to go do something? So how come all these lying things that are relying on this side underutilized resources, but then we have too expensive fabrication? Of course, if you want to have the Indian fabricator in industrial area fabricate your system, he will charge you so highly. But what about if we were able to just retrain, reskill, and mobilize these many unengaged welders, these carpenters that are doing too little to refurbish those things? What kind of systems, what kind of ventures we may need to create to be able to unlock those opportunities for us to make things better? Who designs our furniture? Yeah, even as architects, are we involved? Interior designers, colleagues, all of us who are here, are we involved in figuring out what part of furniture is coming? Right now, we don't think about it because we are going to specify MDF or particle board from PG Bison or from Team Cells. We are not involved in thinking of this furniture, the table we are going to use in this house. We need to design it. And because if we design it, we could be thinking, okay, we are going to pick timber from here and here, and we are going to involve this carpenter so and so, or who are here and build the thing. Could we make better? I'm sure if we were to be involved in designing the furniture, we don't necessarily need to rely on high brand furniture that is imported from Italy to equip our furniture so that we are able to create quality spaces for our people who are exclusive, and then it is 100,000 shillings and imported all over with all those emissions. We could be able to engage in design and improve, make better furniture, bring our creativity into what the Juakali is doing with their limited knowledge, and then be able to liberalize that space, that we are still able to create very nice furniture made from circular sustainable materials, all embracing this local point at a very affordable price, and anybody can get it somewhere within a distance from where they need those products. And then the last part of it, handles matter. Okay? The challenge we are facing is insufficient infrastructure and knowledge to help people understand and manage and prevent waste downstream. So this is basically dealing with a lot more on the logistics. How can we use waste as a resource or dispose more responsibly? Of course, however much we try, at the end of it, we know the material will reach the end of their usefulness. So how can we think of the logistics? What are some of the design opportunities that we have to improve on the logistics, how we handle materials and the products that will be used within our built environment? How can we use waste as a resource or dispose it more responsibly? So how can we make households and businesses more aware of the waste they produce and incentivize favorable behaviors? So for example, think about that your facility in your university, even if you wanted to consider reusing, separating things, what are the incentives you have? Are you made aware? Can our buildings be educating us on how to be more responsible, on how we deal with resources? How can we better track and understand different forms of waste that we produce? We are not knowledgeable. We are not knowledgeable in terms, we are not experts in material science, all of us. But then can we have some basic knowledge to be able to understand these materials, their potentials? How can we encourage households, businesses, and communities to take responsibility for and better manage the waste that they produce? And how can we also deal with the illegalities and inadequate flows? Some of us, of course, as a continent, and some of us within the communities, areas, they become the dumping site. So we have the informal areas becoming the dumping grounds for the waste from the affluent parts of the communities or the city. We have the developing nations becoming the dumping grounds for the waste from the affluent developed ones. So how can we address such injustices? How can we empower informal waste pickers to be able to have more decent jobs so that we are not delivering better buildings, but through unethical and just labor? I'll conclude with the waste ladder. These are ladder. In your thinking, we have these couple of R's that have been developed to help us rethink how we use material. Now, if you look at this ladder, we have recover, recycle, repurpose, remanufacture, refurbish, repair, reuse, reduce, rethink, redesign, refuse. So the three encouraging using waste as a resource. Maybe if you were to forget all that we have said, you could just pick this ladder, and this would be your guiding compass on how we can promote circular design. At the lowest of this ladder, there are some initiatives that have been promoted. For example, recovering materials to produce energy. If you recall in the paper sometimes, or some of you may have heard, the city engaging KenGen, they want to establish a material recovery plant to produce energy from waste from our cities. Yes, that is a good thing, but it is the lowest to do. To burn waste to produce energy, some through pyrolysis, is the lowest value. That should be avoided. It should not be in the priority list. Why? Because it is very expensive. Two, it is also produced a bit of emissions for you. While imagine the much of the energy you need to be able to burn some of the materials until they are able to produce energy, it is very highly expensive. Then we also have recycling, and many are familiar with recycling in the industry. Some of you have heard of Jijenge. We have EcoPost, who are producing materials, for example, paving blocks from plastics that have been recycled. We have many of the brands around there that are already doing this work. So these ones, basically, they process waste into materials that can be used for new products. So you take plastics, go melt it, and then you produce probably another brick. Again, it is good, but second in the hierarchy, because you still, of course, involving a lot, imagine from the collections, the channel, until you take these things to the processing factory, then you use energy, a lot of energy to extract, and then you are remolding to create the new product. It is very intensive. Then we have repurposing. This is where we use discarded products or parts to make new products with a different purpose. Okay, I think that's really self-explanatory. So you are changing the purpose of that particular material. So for example, if I decided it was a pellet, maybe it was a shipping block, then I dismantle that thing completely and then create a chair from it. Remanufacturing, using parts of discarded products to make products with the same purpose. So you are recovering, but then you're going back to the same cycle. I don't have to explain it. Refurbishing this with restoring and improving products to satisfactory state. So much closely linked with repairing. So if you're looking at a door that was broken, for example, you found in the campus, yeah, it may be broken, the doors are handled. We don't necessarily probably need to dismantle that door completely. It could be just refurbished, yeah, improved on, and be reused just for the same purpose that it was intended for in the initial place. Repairing, of course, we understand, maybe fixing, maintaining existing products in good conditions by just probably fixing the broken parts. And still, that preserves, and the whole purpose of that cycle, as you can see that group, their whole purpose is to preserve and extend the life of the existing products without necessarily taking more, degenerating them to low energy, lower value products. Then on the high rank in the hierarchy, we have reducing, basically decreasing the requirement for the material. This is where now as designers, you also want to figure out, probably you could reduce maybe as a design function. Let me use example, for example, steel versus aluminum. Aluminum as a lighter material, sometimes you find probably maybe using timber, aluminum, concrete, vis-a-vis steel to achieve a certain function that all those materials could allow you. Probably you may find that aluminum, in that case, you may use only limited amount pieces of it to give you the same strength, give you the same function you need. But of course, if you're thinking life cycle, you may realize that probably the end aluminum may not necessarily highly competitive. But if you're just thinking in terms of reducing, you may provide probably by reducing the size of the materials, then you are already reducing the demand. Then rethinking calls on us to reconsider ownership and use of products. And that one I've talked about issues to deal with, for example, sharing, thinking of product as a service, rather than just buying the product and owning it and keeping it there as a redundant material in the building and then go dump it. Then redesign. Design products and materials in line with circularity and ecological boundaries. Think about their packaging, think about issues to deal with. How do you deconstruct them? Do you disassemble them? Are you able to encourage repairing for them? Then refuse, prevent the use of products and raw materials used in products. So this is really calling of us to be really responsible, and it largely deals with about reduction in the manufacturing of more and more new products. So in your thinking, as you're thinking about circular design, you want to prioritize the options that are high on the ladder because they generate more value with less energy, with less dependence on the resources. They are the more effective than the ones that are lower in the ladder. And in terms of business models, there are about 5 or so business models that have emerged around these ads. So you have the sharing business models, sharing platform that creates connections and the logistics. You have using products as services. You have reduction in the points. So those models, of course, I think are not so much of interest for you now because you're not creating a business. but I may just touch on them later. And of course, you will interact with them in your slide, especially post the challenge. If you are thinking of what are some of your opportunities, if you are thinking in practice, maybe after probably exiting from employment, if you want to start your ventures, what are some of the things that you could possibly do? You probably could venture into sharing, business models. For example, the Endelevu platform that we have created, one component part of it, the marketplace, reuse marketplace, is a sharing platform. So it is that particular model that creates the linkages. Those who have circular products, linking those who have circular products and provide circular services with those who need circular products and services, so that you reduce that barrier to deal with the things of storage. So you don't need to keep worry about, having a whole warehouse, because you can just quickly get that thing from the virtual platform. You don't have to worry about going to look for yellow pages, calling who and who to tell you, I need this fundi who is able to fabricate this thing, or I need 10 blocks of pellets in Nyandarua, and you don't know who to go ask. You can just get it. So that is, for example, one business model you can think about. But then there are the others that you could look at within that space. So because time is done, I don't want to go into the principles of the disassembly, deconstruction, and waste mapping. I want to defer that to tomorrow. We will just start first with the practical design principle, basically for deconstruction, as well as waste mapping, especially how we are going to conduct the waste mapping. Then when we will conclude the part module 1 on circular design and move to the next module. With that, I conclude my presentation and open briefly. Our time is well gone, so I'm sorry. Are there any reactions, maybe burning reactions, which we can take, or comments, questions, or more than you could reflect on, and we do as I take a recap as we begin the session for tomorrow? Any burning reactions? Okay, so that means then we are okay. Allow me then to conclude the session today. We'll add more materials on the platform. We'll also try to see if we can categorize them later, group them into folders, so that you are able to know clearly which one is which topic is that particular material dealing with. I'll also send, try to find a link to such other resources, like a video, some YouTube videos that you could watch to see, gather more information or build more knowledge base on this particular subtopic. So tomorrow we meet at 9, right? Is that okay?
Yeah, mine is okay.
Great. We still emphasize, remind your colleagues, the attendance is still very poor. Kindly encourage your colleagues to, I know many are excited about, they want to design. That reminds me when we joined campus, many of us first semester was very frustrating, because when we came in, we just thought we were going to be moved straight how we are designing a house, designing a buildings. But then our whole semester, we were just told to draw lines and are doing lettering. That I'm talking for those who are studying architecture. And it was very frustrating, because you're saying, no, we didn't come here to do writings. We came here to build, design, build. We want to create the hub. I hope that some of us who are now walk the journey up to 60 and appreciate the importance of that, laying the theoretical foundation. You are being taught, economics, anthropology, some was a philosophy. You're saying, no. We don't want, we are not going to be social scientists. We want to be architects, technical. And they reserved until later point to begin dealing with other technical topics, because it is important for us to understand the context and be together in the frame of thinking, so that the products we are creating have a story and they are based on some solid footing. So I hope that you can just encourage your colleagues with that same spirit. Let's not take this for granted. It is not just for the designing the hub, it is for the bigger picture of the larger movement that we are creating. So it would be good that we value it and work along together. Enjoy your lunch. We are sending you air burgers online. You can enjoy your lunch and your evening as you work together in your team. Before you leave, sorry, before you leave, let's have a group photo for today's session. Some people have dropped, but the few that are still here, let's kindly let's turn on our video if you can. We don't want to embarrass you. If you can't turn on your video, just turn on. If you can't, just unmute your video so that we can take a group photo for today. Which view? We need gallery view. Okay. Here we are. All right. You can take. You can take, and I take just. Oh, you take mine. I don't. You done? All right. Wow, you guys are very beautiful face and handsome faces. Hi, Janet. Hey, Victor, kwani uko kwa site? Unajua? Victor. Victor was wondering if there was sun. Naona umevaa kofia ama ni brand tu. That is Onyango Shikuku. So, colleagues, I think we got it. So we are good to go. Enjoy your lunch. Bye.
Remind your colleagues as well to join in the coming sessions.
So, and also online, we'll share this as well. You can tweet, Facebook, Instagram, and tag us along. Let's keep the fire burning and see each other tomorrow.